Hey, hello, welcome to the show. It's me, John Park. I was distracted typing over in the chat. Oh my gosh, the show has started. Thanks everyone for stopping by. We've got people over in the YouTube chat. Hello to Dave Odessa, Beata Graf Abdelhagen, Connor McCarter, Johnny Bergdahl, and Charles Burniford. Hello, hello, hello. Thanks for popping into that chat. Somehow, miraculously, Facebook is streaming today. I couldn't get it working the last couple times. I feel like I used the same settings. But if you're there, if you're in Facebook, hello. If you're in the chat there and it seems awful quiet, then I would love to recommend that you head over to our Discord, which is right here at adafruit.it/discord. Jump into the server and then look for that. Right there is the live broadcast chat channel. And that's where people are hanging out during the show. We've got Johnny Bergdahl there as well. Hello, John Nodge and WA90NY. C. Grover, Thin Man, hello. Thanks for popping in. Let's see what's happening. The show consists of some coupon code action, a wrap-up or recap of my product pick of the week, a CircuitPython Parsec, a couple of little project kickoff-y kinds of things. So you may have noticed, you can see down here at the bottom, it says test patterns. So I've got some stuff I'm going to do using the Fruit Jam. And Fruit Jam is not quite out yet, but I have a beta board, one of the earlier revisions. I think there's a newer revision than the one I have, but it will work pretty much the same way as a Metro RP2350 plus this little HSTX to DVI breakout, but it's all built on board. So I won't be using any of the other fancier features that are on it, like USB hosting or anything like that. But I do want to show some neat stuff involving test patterns, only because I just got the board up and running yesterday, the day before, and I was plugged into a small HDMI monitor, and it looked awfully stretched out to me, and the monitor I was using did not actually have a capability of fixing that stretch. But I wanted to be sure what I was looking at, so I decided to make some test patterns, some video test patterns, inspired by classic video test patterns and some that have been collected into something called the 240p test suite, which you may have seen me use before on CRTs. It's designed for testing out your connection between usually retro gaming consoles and a CRT or a PVM or a BVM. So I'm going to show some of those just running on a HDMI monitor. But the stuff I'm showing there will work on RP2350 and HSTX pretty much without any change in code. The pin names are the same for the HSTX stuff for this example. So, and I may also show another SNES, Super Nintendo Entertainment System related thing that I'm thinking of launching and kicking off on also on Fruit Jam. So those are the upcoming things. As I said, I've got a coupon code for you, Monoscope. If you want to head over to the Adafruit shop and save some money, then that's the coupon code for you. It is going to get you 10% off until midnight tonight on pretty much any physical thing that you can buy in the Adafruit shop. Will not work on gift certificates, subscriptions, or software, but you can head on over right there, Adafruit, and look for neat things. For example, new products. View all new products. What do we have here? Hey, let's say you want a Cytron Motion 2350 Pro. You get 10% off of that. How about this new feather, ESP32S2 with the antenna, 1750. Pretty cool. Nice setup. If you're thinking of doing some wireless stuff, that may be worth looking into. And the list goes on. We have loads of neat things in here which you can save some money on using that coupon code that you see right there, Monoscope. Just type that into the coupon code slot on the way out, and you'll get that 10% sliced right off the top or the bottom. I don't know where. There's a bug flying around. Let's see. I thank you for who said that? Thin Man. Hope your workshop goes better today. Referring to Tuesday when I decided to blow up the thing I was testing. I completely fried the little board I was testing, but I took the time to go grab a backup and solder it together, and it worked. So it felt good to me. I like a storyline that had a bit of an arc to it, a triumph in the end of the thing working. But yeah, I don't need that all the time. So thank you. I appreciate the sentiment. Let's see. Next up. So this, in fact, through the magic of editing, my little 1-minute excerpt didn't really have the space in it for the full storyline. So go watch the live stream recap if you want, or the live stream itself if you want to see that. The recap I edited together so it all works from the beginning, and this is it. This is the product pick from Tuesday, and here's my little 1-minute excerpt with nothing getting blown up in it. PCM 5102 I2S DAC. This is a line level output DAC, high quality, low signal to noise ratio, so you get a beautiful audio out coming from digital on your microcontroller out to stereo audio over a 3.5 millimeter TRS jack. Here I have a QT Py, this is RP2040, and then here is my PCM 5102. I'm going to plug this in, and now I'm picking up the ground, power, and the 3 I2S data pins here. Then I'm going to plug into some powered speakers over that 3.5 millimeter jack. PCM 5102 I2S DAC. Mighty suspicious. Yeah, did you notice the fried one up above? It totally got fried. I was, as Todd said in the chat, it is hard to design boards that are resilient to off-by-one errors on a breadboard. It's sitting here in the trash. I decided I'm not even going to mess with trying to desolder anything and fix it. Sorry. The 3 volt is right next to, V in is right next to ground. So I had that shifted by 1, which meant I was pumping the 3 volt into the ground and still had a ground loop from some of the other pins, I think. So I just... who knows? It could be a simple fix, but I just simply don't have the time for it. I'm sorry. And they're not expensive. So that was it. Off by 1 error. Oops. Okay, so... next up, let's, yeah, David S. asks, did I manage to repair? I didn't try. Now I feel like I'm disappointing myself and everyone else. Should I try to repair it? Maybe I'll fish it out of the trash. I'm going to stick a Post-it on it. Good lesson for us all. That's right. I blew up this board, so you don't have to. All right, I'm going to, whenever I see a Post-it note impaled on a board, that's my sign to myself that I probably shouldn't just use that without investigation. Yeah, there was no magic smoke. Todd says, I don't think it's repairable. I wish there were. I wish there were magic smoke always. That would be so helpful. In fact, I was thinking, could we get like a very small, like 0805 surface mount Semtex charge on here? So if you do, it'd be great. I just want a hole blown right through the PCB so it's very obvious. You broke it. It's not software. It's not the rest of the circuit. I don't know. Maybe that's a bad idea. That's probably a bad idea. I think I know. I think I know that's a bad idea. Okay, well, let's now move on to what is perhaps a good idea, and that is this right here, the CircuitPython Parsec. CircuitPython Parsec. Okay, yes, so right here for the CircuitPython Parsec today, I want to talk about using Unicode characters, particularly Unicode boxes and blocks, in the REPL to help with visualizing things in your code. So this is an extension to some degree of last week where we looked at the ANSI escape codes to be able to do things like refresh the screen without just creating a stream of data, moving the cursor around, sending very specific color codes and inverse codes and things like that. So one of the things that I had originally done this for was to make a little visualizer, like a VU meter for myself. And one nice way to do that is with Unicode graphical characters. So if you look in my, I'm going to go ahead and resave. If you go ahead and look in my REPL down here right now, you can see I've got a bunch of interconnected circles being printed. I'm going to go and change one thing right here. I'm going to change this to a full block and print that. And you'll see I get this nice thick bar across here. This is actually 6 copies of the Unicode rectangle, one after another. And so the way I'm doing this is I'm creating a variable, just for convenience here, that is, in quotes, \u, which is what tells it we're going to be using a Unicode character, and then the Unicode number, in this case 2588, which is this rectangular block. Then in my main loop, I am using the ANSI escape codes to clear this screen and put the cursor right at the beginning of the line. I'm putting a blank space, and then I'm printing 6 of whatever the current block code is. So if I go ahead and make this a half-width version of that, which is Unicode 258C, and hit save, now you see I get this little 6 boxes that have a little space between them. And in fact, let's see if I can zoom this up a little bit bigger for you. My code is nice and short here today, so you can see those a little better. And then for myself as a little reference, I've printed some Unicode characters that I might want to try out and what their codes are and their names. So for example, we can make a little row of teeth. 258B is the white down pointing triangle. 258B. I think I got that wrong. It is 25B3. I misread that entirely. 25, oh, and I typed it wrong. 25B3. Here we go. Save. Oh, those are the upward-facing ones, and then what were the downward-facing ones? D. Hit save. And so there you can see I got a nice little set of graphics there that you can't really use just ASCII art for. These are a little more specific than that, specifically designed graphics. And you can look online if you go. There's a nice Wikipedia article that sums these up, all kinds of Unicode characters that you can use. And there's some sort of a chicken and the egg thing sometimes of like, well, if I don't have one of these to copy and paste, I can't really put it into my code. And where do you store these? So I like having these Unicode characters available as a way to use some different interesting graphics. Now, as a example of why I would go to all this effort, I'm going to go ahead and minimize the code here, and I will comment that out. And now I'll show you a little bit of example code where I'm going to use both Unicode characters for those little blocks and the ANSI escape codes so that I can refresh the screen from the top every loop that I go through. And I'm going to use that to graph the voltages on the 6 analog input pins on this Metro board right here. So I'll go ahead and save this, and I may need to expand the screen a little bit. And you can see here, I don't have anything plugged in, but if I put my finger under there and I'm essentially pseudo grounding these analog pins that are floating otherwise, you'll see I get a sort of little neat VU meter of those 6 readings, and I'm using the Unicode characters to populate that little graph there. All right, so that is Unicode, I think 3 or 4 of those little Unicode blocks, and then a fairly simple bit of code to determine where to draw those blocks based on voltage. The voltages are printed at the bottom too, so you can see I get these up to about 3.3 if I fully ground them, and they float around 0.1 or so, 0.2. So that is how you can use Unicode blocks in your CircuitPython code in the REPL along with ANSI escape sequences to do some graphics inside of the serial output. And that is your CircuitPython Parsec. And I wanted to show you, here's a nice list here. If you go just to the list of Unicode characters article in Wikipedia, you can see this whole 25XX section of the Unicode is a bunch of neat graphical boxes and glyphs used for making corners. You can draw bigger boxes, mazes, things like that. Yeah, you can do terminal games. Squid.jpg said, time to make some terminal games. Oh yeah, you should definitely try that. That would be pretty cool. I'm not sure which of these will display on a screen. The terminal of choice that I'm using that you're using will dictate how well you can display these characters. So just plugging into a display. In fact, if I plug this into an HDMI display using HSTX, we'll see some of this stuff show up in the REPL, but I don't think most of it. WA909NY asks, what IDE are you using? I'm using Zed. I'll go back to it here for a second. This is Zed, which is from the team who made Atom. I used to use Atom. Atom kind of died somehow or something. Switched over or back to Sublime Text, but then when this came out, I liked it. One of the things that I was just in the habit from Atom of hitting Control tilde to open and close the terminal at the bottom, and Sublime Text didn't do that, but this one does. So I kind of liked just being able to pop that open without going up in the menus. Zed has a terminal plug-in, asks Todd. Yeah, I guess maybe it wasn't installed by default. And will it tell me in some obvious way? I set it up and then I kind of forgot all about it. Yeah, maybe I added this. This might have been an add-on. I don't think it was Terminus. Good question. Maybe I'll do that for a little tooltip sometime. Now I honestly now can't remember what terminal program I'm using and how. Let's see, if I close that. Yeah, so I just hit Control tilde or Control back tick to open that. No idea if that was installed by default or if I added that on. Can't remember now. Try it though. If anyone has Zed installed and doesn't know about having installed a terminal, okay, it doesn't toggle it open and closed. It does shift some focus between the two, which is interesting. But if you open up Zed and hit Control tilde, it, at least in my case, pops up a terminal. Todd confirms, yes, it's in there by default. Fun. Yeah, and so this is a full-blown terminal. So you can install, if you're not using it, actually I should say, you can open multiple tabs in here if you hit plus, new terminal. So this is pretty cool because that means I can, I use Disco Tool to connect to my CircuitPython board. But if you, let's say at the top of your code, wanted a plugin or a library rather that's not installed. Let's see if import NeoPixel. Is NeoPixel installed? Darn, it is. What's one that's not? Adafruit. What was the one from last week? DAC 250X. Is that right? So it says it doesn't have that. I might have made that one up. Does that exist? Let's find out. If I head over here into the second terminal, I can use circup, install Adafruit DAC 250X. I feel like that's not it. It's going to try. It's going to download the bundle. We'll just pretend it worked. Yeah, that's not known. I made one up. But you get the idea. It's kind of cool. You can sort of live inside of Zed here with enough terminals up to do whatever you're doing. Cool. So let's see. Next up, let's look at some test pattern stuff. Why don't we? I'm going to go. In fact, I'm going to head over here, and I guess I'll put a little. I'm going to shrink down the little overhead view. I don't think you'll need that one so much. But let's head over here, and I will try to bring up my. I'm going to try to not trip over a bunch of cables too. And bring up Discord so you can let me know if anything wacky goes on. And so what I got here, Super Nintendo. Ignore this. This mouse is not connected at the moment. I've got a pretty standard controller plugged in. I've Indiana Jones' Greatest Adventures. All right, let's just power that on, see that working over here on this TV. Actually, it looks pretty good. And it's fine. You can play and be happy. I do notice some little fuzzy pixels in the corner over here and some other things. So if you want to get in and adjust settings on a monitor, and it doesn't just have to be CRTs, you usually want to use a standardized test pattern to let you know how things look. Super Mario Brothers is actually pretty good. It's got a nice intro screen that has a lot of color and some good shapes in it, so you can use that in a bind. I did at one point, however, buy a cartridge someone had burned of the 240p test suite, which you can get the software free, and if you have like an EverDrive or some other way to get games onto a machine, you don't need the commercially available cartridge. But either way you do it, this is a pretty standard test pattern suite. And if I go into the test patterns menu, I can take a look at things like color bars, right? So this is going to show me, am I seeing any red in column 1, row 1 here? Or 0 should probably be black. But this is sort of a set of gradients of intensities of some colors. Here's a version of that that's on top of a grid that we can use to check for the ratio, the aspect ratio, if it's off. Those are looking a little stretched. In fact, there's a full-blown grid here. And you can use this one to see, okay, usually we can push the horizontal and vertical, the width and the height, a bit in settings for your TV. To get the red ones off or mostly off the screen, because those are usually not an area that's used by a game. Usually the safe area would be inside these white ones here. But I can see they're looking kind of blurry in the corners. In fact, if we look at a convergence test, these should all be white dots, and since this is and I'm sorry, I know you can't, I'm not zoomed up on this enough for you to see, but I'm seeing white dots, and then I'm starting to see a shadow of some blue hanging out, and up here I see a distinct red, a green, and a blue dot. So we're spraying pixels around at the or rays as the rays sweep and scan here. So there may be some settings that you can adjust with magnets and things like that to be able to fix your TV. But to know what you need to fix, you want a grid on there. Okay, so this is a little in the weeds of CRT stuff, but with even my HDMI monitor that I was using, that I was talking about earlier, to send stuff from the Fruit Jam or from the Metro, I wanted to know, well, are my squares square or are they rectangular? So something like this monoscope, this is a version of a monoscope, can be used to look at some line thicknesses and some problems. This one actually shows convergence problems pretty nicely in the corners here because of the white that's right at the edge. So I wanted to use those, and even the very classic SMPTE color bar, especially if you have like a reference chart, if you're doing some color critical stuff, you can compare to something that's a proper reference and see, does this yellow actually look right? Or take it to the sort of ultimate step if you're using color calibration dongle that you suction to that. In the old days, we did these on CRTs for graphics stuff and animation in order to have sort of a closed loop between color values being read by a known good color sensor and what's shooting out the screen. So these are some color charts and geometry charts that are useful. I can't remember if this one has some linearity. Not that one. Let's see. I think maybe the monoscope, if we go to the options. No, does not. But it's nice to get circles up here, and I forget if there are circles available on any of these. Let's see. Check grayscale. Color bleed too. This will show you if you've got colors bleeding between spaces. Does the grid go to a, nope. Gray ramp, white reference, IRE, sharpness. That one has a circle. So that one's pretty useful, but I actually made a few of these in CircuitPython that I want to show you now. So let's power that down and head back over here. So I made some of these in CircuitPython that I can use just for little HDMI monitors to check and see how they are doing. Yeah, Todd says in the chat, of course, if he's got a game console and finds a way to get test patterns out of it. So the reason that's actually kind of neat and funny is that it's fairly inexpensive compared to TV repair, and video technicians often had dedicated hardware that generated these patterns. So you'd plug in a hardware tester, and it had baked into it a series of tests that you would run through. So this is kind of a retro gaming version of that. So what I'm going to do is let's switch to the down shooter here. And so this is the little monitor I'm using. This one's what, like a 7-inch? Yeah, I think this is a 7-inch HDMI monitor. That we have these in the Adafruit shop, and I really like these because they've got an HDMI in as well as VGA and composite video. I think that's an audio out there, and this is just a 5-volt USB that you can use to power something. So I'm going to bring into the frame here. This is a Fruit Jam, earlier revision than current, which is essentially a souped-up RP2350 with dedicated, for our intents and purposes, this is the big thing, is that it's got this HXTX DVI video output in the shape of an HDMI plug, just bolted right onto it instead of as a separate thing. Plus it has USB hosts and some other neat stuff. But for what we're doing here, this would totally work on the Metro RP2350. So I'm going to plug this in and power up the monitor. And let's try to fix the camera a little bit. And I'll get you some focus on that. Oh, where'd my little stylus go? Oh no. All right, there it is. Let's take a look at. That's pretty sharp. Okay, so I'll show you a few of these, and then we can take a look at some of the code. So I'm gonna. This one is essentially a SMPTE chart. I just have a little bit extra gray coming off of there, but that tells me, you know, if I see colors out of order, because you can look online and see what order are these supposed to be in, then you can tell if you've got a color swapped. So that's one way. Even more directly, though, is this red, green, blue, white chart. So let me find where I put those. Fruit Jam, video test patterns. Let's do color bars, RGBW. So I'm going to just overwrite the code.py that is on the Fruit Jam here. And oops. There we go. Save that. And one of the nice things here is you could do these as graphics, but then you're trading BMPs around. So I thought it'd be nice to do these just in code, mostly using display.io. And so now you can see I've got, I may revise this, but this has some fairly standard intensities of the red, green, blue color components, and then those combined. So that's great. If you've got those out of order, I've got the names there, so the word red should be in red, the word green should be in green. So you can tell if things are somehow screwy. And if you want to take a look at what my initial concern was, am I stretched or not? Are things in the proper ratio? Because these little monitors can do 4:3 and 16:9. Often those are just two items in the menu. And some of them don't get that right, even though what's coming in should be obvious to it. And sometimes the settings are auto and they get it wrong, or I have another one that just plain won't let me fix it for some reason, even though the item is there, it's grayed out. So I'm going to show you a couple that I can use to check for linearity and ratio. So let's do our grid of squares and dots. So there you can see, and I've got a little piece of on-screen display overlay that pops up there, but now I can see, okay, good. We're not having any overscan or underscan issues. These red lines should go all the way to the top and bottom, and then here you can see the difference between what the 16:9 and the 4:3 would be. So we've got these pillar boxes. That's good, right? This should not be stretched all the way to the sides, and if it is, it should still be squares. It shouldn't be rectangles. So those are all ways that you can test the display you're plugged into. Let's see, over in the YouTube chat, Jason Edelman said, "Yay, Fruit Jam! I can use my HDMI to DVI cable and DVI only Sony LCD." Oh, excellent! Yeah. Never get rid of a cable, because things may come along and let you use your old monitors, which is great. So let's take a look at the other one for linearity, which is some nice circles. I'll show you now the IDE view. So where is my circles? Linearity circle. And I may try to make these like separate modules that I can put on disk and then call them from one piece of code.py, or maybe use the buttons on the Fruit Jam here. But this sort of Mickey Mouse-ish turtle-looking thing. Again, these are circles that go right up to the corners. I think I have a few pixel space there, so they shouldn't touch, but right up to the corners of the screen, and then almost touching this one. If those are way off, then you know. So here, let's take a moment to fight the menu on this thing, which is maddening. Let's see. No. Okay. Menu almost always goes back, doesn't it, on this one? Let's go. Oh, good grief. Okay. Switch goes between them. Menu back. Okay. Aspect ratio. 16 by 9. Okay. So that's what I was seeing before, and that's not what I want to be seeing. So I want to get this. There we go, to 4 by 3. All right, I'll leave that alone. This is my least favorite part of this monitor is the confusing use of buttons to try to navigate that thing. And I'll take a look at, for example, let's take a look at this one. This one is using, all of these will use this Pico DVI library in order to send out DVI video over HDMI cable to your monitor. And then I'm using display I/O and frame buffer I/O to create shapes and to draw them. This is the setup right here, which is actually sending a 320 by 240 screen, which is then being pixel doubled onto the display. And the setup here is the HSTX setup for all of the pins for, I believe these are differential pairs for data on red, green, and blue. The color depth is 16, and then these are pins used for clock to get that signal right. So we set up our display as a frame buffer. We create a bitmap, in this case just a 2-color one because I'm just doing black and white. Define my colors. So if you wanted to change that right there, you could go to purple. Test your colors that way. Creates a tile grid, and then we're setting the background to black and drawing a few circles of different radiuses, which we could probably use display I/O shapes for, but I was working with Claude AI, and this is what it spat out. So I should preface this with Claude AI did the heavy lifting on the coding, because I didn't want to look up formulas for circles or even remember how to use the circle primitives. So. Quick and easy. Let's see, anything else interesting in there? Now let me open up one other example. This is this box scroll. So moving beyond the, oh, did I grab the wrong one? Let's copy that. Moving beyond the static images, I also wanted to start just looking at doing motion on this. And so I've just got a simple box moving along, and I wanted to add a little bit of interactivity with the buttons on the Fruit Jam. So I've just got, there's 3 buttons along the side here. One is shared with boot, so you can use it as the bootloader button along with reset, or hold it while you plug in to put the board into bootloader mode and load new software onto it, new UF2. But you can, once you're up and running, use that as button, board.button, board.button1, and board.button2 to switch that to blue. Also shows me that actually my display is showing that kind of a little more cyan-y light blue, so I probably got some white balance issues there I can maybe play with on this camera, but those don't look great. I'll leave that alone. So this code, similar sort of setup on these. They're all going to use this same setup. And then you can see I'm using input pull-ups for button 1, button 2, setting the same black background bitmap. I've got a little square on here. We can change the size of that. Well, let's make it small. There's a little tiny box. We can move that pretty fast and smooth. Let's just move 2 frames per pixel, and we'll go a lot faster, so that should zip along So just the basics here. And we should still be able to change the color of that. John Nush says, it looks like an intro to a Minecraft James Bond movie at first. So anyway, those are some of my test patterns. Let me see if there were any other interesting ones that I didn't show. Oh, this one's kind of cool. I just wanted to take a checkerboard and move it from tiny to bigger. So every 3 seconds, we just go up to a larger checkerboard and loop that. And I'm not doing anything that's drawing these all that fast. So it's kind of a slow refresh of the whole screen every time right now. Let me see, do we have any others? Color bars we looked at, yeah. I think those are, yeah, those are what I wanted to show. So that's me getting feet wet just a little bit with Fruit Jam, and my very first step was, do I trust my, my monitor and the output to it? So this is something I'll be able to use for that. And then I've got some ideas. Actually, one of the reasons that I brought this out over here, let's go to this bench cam again, is I want to, let's see if I can turn this microphone back, that's back there on. Let me know in the chat if that becomes super noisy. I just turned on a second mic. Lamore suggested that maybe I take a look at, since we have mouse support on the Fruit Jam, what about trying to replicate something like Mario Paint, which had a music composition section of it. So this is actually the SNES mouse. It's a real rollerball mouse, old school, 2-button. This game does not really make use of the second button, sadly. It would be really nice if it did. It's a clunky interface, but mine, I can make maybe that improvement. And hopefully you can hear some of the music coming out of that. So let me know, do you hear any music coming out of that? It's not 100% necessary, but it'd be nice if you can. And I have a mic that's just up against the speaker on that CRT there. So let's click on Mario there. I love the loading screen of some sit-ups and a pop to handstand. What? So this is Mario Paint, which I'm going to ignore. And I head over to music section here. And in fact, just so we can test if you can hear, I'll just play this one. This is just a sample song here. So you get this little, I think it's 24 bars, a little music staff, little treble staff here. You can play 3-note polyphony. And I believe these are samples. I'm not sure if any of them are synthesis. Maybe that some of them are synthesis and some of them are samples. Maybe it's all synthesis, but I'm pretty sure some of them are samples. So let me know in chat if you can hear that, and I'm going to hit stop on that. I'm going to clear that screen. I'm going to go to the beginning here, and I'm just going to set like a 2-bar loop. So you can set the end point right there, and it makes all kinds of fun noises as you go. And there are no conveniences. You can't hear that audio much. Okay, thank you for that update. I'm going to put the volume up on this a bit. And let me just check that mic cable that's going into there. I'll lay down a couple notes and then play that. And again, we can check. So what you have across the top, can you hear that? Oh, maybe, I wonder if I only have one speaker working on this TV. Let me try to move this over here. That's probably really annoying loud noises. Sorry, okay. Tell me, can you hear? Yes, sounds good, okay. Probably turn this down just a bit. Thank you, Todd, in the chat for letting me know. I can't see the YouTube chat right now, so thank you if people are telling me there. And let me see if I can zoom this camera in a bit. Okay, that's a little better. So what you have across the top are your different samples or synth sounds, voices that you can use. So we've got a little Mario here. We've got drums with this little mushroom one up. Little Yoshi does a kind of Yoshi noise. You heard the little star before. Now these are pitched in their sample that we play, a little trumpet kind of sound. It's a nice little Game Boy that makes a little sort of square wave. But when you go and click on the staff, you can lay down 3 notes on the staff there. I don't think there's a way to preview the pitch without just playing it. Oh, my head is going there, which is too bad. But if we lay down some little chords here, and play that, I think I need to tell you to loop. So obviously I've got this just playing as 2 bars, so it's going to get real repetitive real fast. We can then decide, okay, I'm not going to waste all 3 of my notes on these little Game Boy square waves, so we can go in and erase, 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 erase. Oh, I can see all the notes at once now. That's nice. And we can just lay down, let's say, a kick drum by placing it real low. Boom, 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 boom. So that's Mario Paint's music program, which is pretty cool. Lots of other samples in here. Meow. Meow. The goose gets the really cool orchestral stab there, which is amazing. What? These are slightly more sustained notes over here. Not that one, this one. Which is nice because you don't get to change the length of any songs, any notes. It just plays. Which is too bad. The heart is a very cool bass. A couple other funny things about the interface. You hit this bomb not to blow up the screen or get rid of stuff, but to just leave this module of the program, which is really weird UI design. You can also open existing songs. There's actually a really good, I'm going to trash my song and open up this one, this sample that it comes with. Oh, that's not the one. Wait. Not that one. This one. I think that's as long as we can go. Yeah, it's a full song. And you can also, we're going to leave that module, scarily enough. Go to the robot, load up a existing song, and it's actually the full session. So any animation, painting, sketch stuff, stamp stuff, song stuff, all the different modules that are in there, it loads them all. It takes forever. Oh, I didn't hit start. I wish I had, because at least saving takes forever. Let's see how long this is going to take. Oh, was that it? It's pretty fast. Saving is forever. Takes forever. Okay, so if we go back to music, this is something I composed earlier that I'm super happy with. It's short though, so needs to be added on too. Anyway, that's the Mario Paint SNES cartridge music module. And now my goal is, can I recreate that? Not get an emulator with an SNES on the Fruit Jam, but can I get a rough facsimile of this type of sample-based or synth.io-based? So either little waves that we can play back using audio mixer, and then have some amount of graphic overlay. I suspect the SNES is a lot better at scrolling and sprites than CircuitPython will be, so it may not be a Mario running across the top as we play kind of thing. It might just be all stuck on a screen, but the basic concept of, can we use a mouse with the Fruit Jam in order to place down some notes and play them back. They could not only be audio that we hear using synth.io and or wave playback or MP3 playback. Can I also send out MIDI? So can it be a little MIDI composer, basically? Those are a couple of the ideas around that. So that's what this is all about, as well as, of course, a fun excuse to fire up the SNES and Mario Paint. Squid.jpg says, yeah, I love that Nintendo put so much effort on this and there was no real way to even share your creations at the time. It's true. I've got a VCR over there, so I could make a tape for someone of the Mario Paint creation and send that along. Let's see, what else? The can't hear anything different, kind of better. Okay, yeah, thank you. Connor McCarter said they could hear that a little bit better on there. I'm sorry I didn't get a chance to test that on headphones. But the idea is, can this thing right here get us part of the way there? These are USB host ports with a hub chip. I've used a keyboard on it so far. I haven't tried a mouse. Keyboard worked. Some keyboards didn't, so I'm not sure yet what causes. Some might be current draw or something like that for a lighted keyboard, not sure. But anyway, excited about this Fruit Jam because it brings together a lot of these retro game console and 8-bit, 16-bit computer era ideas into one little thing. All right, I think that's going to do it. Hey, thanks so much for stopping by. If you want to go grab some stuff from the store, that's what we do. We try to show you neat stuff, encourage you to buy some so that we can just repeat that process. So Lemoore can design more stuff. People can write the libraries and software to make it all work, and I can make some tutorials for you. So that's our whole plan right there. We're pretty transparent about it. Buy things, and we'll keep doing all this. And of course, the community, thank you so much for being here, for hanging out. If you want to go check out other neat stuff in the community, head over to our Discord and look at some of those other channels. There's general chat. We have help with CircuitPython, help with 3D printing, help with Arduino. Big news, the 20th anniversary. Can you believe Arduino is 20 years old? 20th anniversary Arduino Day is coming up. We'll have some things going on related to that. But this is a good place to go and hang out for general Adafruit community things. So thanks for being part of that. And of course, thanks for stopping by over in our YouTube chat to everyone who stopped by. We appreciate you. I think that's going to do it. So what's happening next? Foamy Guy, who is working on various cool game stuff, both on, I believe, the Metro RP2350 as well as Fruit Jam, has been doing some cool, and in fact, one thing I wanted to do that I forgot is guides. If you take a look right here, Learn Guides. Let's go to the Learn Guide home. Right here, you can see here's some updated guides. Here's the LED Matrix Wall Arcade for Pico 8 guide that I just finished. You probably saw me working on that the last few weeks, so that is up and running, and I'm making just a couple little text tweaks and things for clarity right now, thanks to my friend Usman, who pointed out some things that could use additional clarity. But this is up and running, and in fact, next week I might bring it back on because I made the switch to no serpentine mode, so all 4 of my panels are facing the same orientation now, which actually got rid of a little blue line artifact I was seeing. You just need a longer IDC cable. So I got that cable in yesterday and took it apart and rebuilt it, and it's now perfect. Chef's kiss. So if you go and take a look right here in the other new guides, there's this snake game on Metro RP2350. Which Foamy Guy put together. He'll be talking about, I believe, some of these graphics tricks and things that he's been doing both on Metro RP2350 with the HSTX DVI output as well as on the Fruit Jam. So that is a great place to check out stuff that Tim is working on the deep dive tomorrow. And then there should be a Desk of Lady Ada this weekend, and back on Tuesday with another product pick of the week with me, and then Wednesday morning, 3D Hangouts, afternoon, show and tell, evening, Ask an Engineer. So those are all cool things coming up. Thanks everyone so much for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. See ya. Bum, 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 bum.
Sorry.